Okay. So a perfect square always seems to have a sum that's odd.
Well, I think that's true because either it'll break down like this one did into odd squares, or in the case we have an even and an odd, you get an even square and an odd square. You would have three odd numbers. You'd have the odd number to the 0, to the first, and to the second.
Okay.
And in the case where it's just one number squared, like if it's one odd number squared, all the factors are odd, so you don't. Well, it breaks down like this again.
Okay.
And if it's an even number, that
You have
a
one.
power of 2, that's a power of 2 squared.
Mm-hmm.
You just have 1.
And that's your odd number.
Yeah, that's the only odd number.
You need to have an odd number of odd numbers.
Okay.
You really need to have 3.
All right. So you guys are getting actually pretty close to this. So a perfect square is going to break down into 2. So if I have x squared, just some random square,
X squared.
it's going to be factored into 2 to some power that's even, right? Because it's
Yeah.
a perfect square, times a bunch of odd primes now. 2n1, I'll call it. 3 to some even power. 5 to some even power. All the way up. Okay? So it's going to have 2's, 3's, 5's, 7's, whatever, a bunch of prime numbers. But all the powers are going to be even. Okay, so when I make my buckets, how many choices do I have in my factors for powers of 2?
Well, you have 2. You'd have
An odd
2
number.
and 1 plus 1,
2n1 plus 1.
which
I have
is an odd number.
Yeah.
And then
How about for the 3's?
you have
2
2 and 2
2.
plus 1.
Okay. 2 plus 1, 2 and 2, and then etc. Okay. Now I want to sum up the divisors. Anytime I use a power of 2 that's different than 0, I get an even number, right?
Yeah.
Yeah.
So that's going to contribute an even number to my sum. So the only way I can contribute odd numbers are what power of 2 do I have to use?
You have to use 2 to the 0.
I have to use 2 to the 0. So the only time I get odd numbers is when I have 2 to the 0. And how many choices for odd numbers do I have then with 2's?
Well, you have. Well, you.
For odd numbers with 2's,
Yeah, so if I want to have an odd factor, how many choices do I have for what power of 2 I can
well,
use?
you can only use 2 to the 0, so
Right.
1.
So I have one choice. How many choices do I have for the 3's? Do I have any restrictions?
No,
No,
because it's always odd.
always odd.
And the same for the 5's.
Same for the 5's, same for the 7's. So I have one choice for my 2's, 1 times an odd number, times an odd number, times an odd number, times an odd number means, do I have an even number of odd numbers or an odd number of odd numbers?
Well, you're multiplying, so it doesn't matter how many odd numbers you have.
Right?
It's still going to be odd.
Why?
Because an odd number times an odd number is an odd number.
Okay. So I have an odd number of odd numbers, no matter what, with a perfect square. So you guys noticed that, and that's really good. That was a great thing to notice. Okay?
Yep.
All right, so let's go back up to the computer and see if we can figure out the very last question we were working on.
Okay.
When is the sum of the divisors
It's odd.
Prime.
prime?
Alright.
And what did you think was the answer to that question?
Well, we found a few, but they didn't seem to have any pattern to them. Like there was a prime and a few squares.
Okay. Sometimes seemed to be, there was one prime number that worked,
Yeah, that was 2.
2, had a sum of 3, and then some perfect squares had a prime.
Yeah.
Okay, so let's see if we can use the computer to illuminate that question a little more.
Alright.
Okay.